What is the difference between a mini-computer and a microcomputer?
The term mini-computer is not used much today. It is considered to be the type of computer built mainly from about 1963 to 1987, and refers to the mini mainframe computers that were not large enough to be called mainframes but were large enough to take up the space of a small closet. These computers were once popular in small businesses that could not afford the money or space for a mainframe computer. They were much less powerful than a mainframe and were limited in hardware and software. And they were built using what was called low integration logic integrated circuits. Eventually, they were overtaken by microcomputers built around the microprocessor. The microcomputer was a later development in computing. It was developed as a general-purpose computer designed to be operated by one person at a time. The single-chip microcomputer, complete with microprocessor, was, in many respects, a landmark development in computer technology, resulting in the commercialization of the personal computer. This is because computers became smaller and less expensive, and the design made parts easier to replace.
What is the Mozart effect?
The Mozart effect is a term coined in the 1950s by physician and researcher Alfred A. Tomatis, 1920 to 2001. It refers to the supposed increase in brain development that children under age 3 experience when they listen to music composed by Wolfgang Amadeus Mozart, 1756 to 1791. A more recent interpretation originated in 1993 from physicist Gordon Shaw and Francis Rauscher, a former concert cellist and expert on cognitive development. After a few dozen students listened to the first 10 minutes of Mozart's Sonata for two pianos in D major, K. 448, the researchers determined that the students experienced a short-term enhancement of their spatial temporal reasoning, based on a certain IQ test. But many other researchers claim that no one has ever been able to reproduce these results. Over the years, the Mozart effect has reached further into the public psyche, with highly debated claims of better health, memory improvement, and therapeutic uses of music, especially classical music. Proponents also claim the Mozart effect can be applied to learning such subjects as mathematics. They believe that exposure to certain types of music, especially classical music early in life, leads to higher future scores in spatial visualization, abstract reasoning, and sundry other mathematical concepts. But all these claims remain highly contested.
What are the probabilities and odds of being initially dealt certain hands in 5-card poker and bridge?
Because there are a certain number of cards in a playing deck, mathematicians have worked out the probabilities and odds of being dealt certain hands for certain games. The following explains the odds in terms of chances against, chances for.
Why did the Egyptians choose the pyramid form?
Historians know that the Egyptian sun god, with its rays reaching for the sun, was represented by pyramid-shaped stones, or benbens. And because the Egyptians worshipped the sun as their chief god, the pyramids are thought to be huge renditions of the benbens. After a pharaoh died, the pyramids would be symbolic of the pharaoh ascending the sun's rays to join his sun god. Some historians also believe that the pyramids may have had some, still hidden, numerical significance. In particular, some believe the ratio of the pyramid's perimeter to its height times 2, or p/2xh, gives a close approximation to the value of pi. Another claim is that the slopes of the pyramid sides were also expressions of pi.
What is the importance of pi?
It was used in calculations to build the huge cathedrals of the Renaissance, to find basic earth measurements. And it has been used to solve a plethora of other mathematical problems throughout the ages. Even today it is used in the calculations of items that surround everyone. To give just a few examples, it is used in geometric problems, such as machining parts for aircraft, spacecraft, and automobiles, in interpreting sine wave signals for radio, television, radar, telephones, and other such equipment, in all areas of engineering, including simulations and the modeling of a building's structural loads, and even to determine global paths of aircraft. Airlines actually fly on an arc of a circle as they travel above the Earth.
What is the beast number?
The so-called beast number is 666, a number that is mentioned in Revelations 13:18, here is wisdom. Let him that hath understanding count the number of the beast. For it is the number of a man, and his number is 666. It is also thought of as the number of the Antichrist. There are other related numbers that have gained cult aspects, too. For example, a number having exactly 666 digits is called an apocalypse number. A number of the form 2n that contains the digit 666, in other words. Powers of 2 that contain 3 consecutive 6s in the decimal representation is called an apocalyptic number. 2157 is one such number. It equals 182,687,704,666,362, 864,775, 460, 604, 089, 535, 377, 456, 991, 567, 872. The first few such powers are 157, 192, 218, 220, and so on. There are also some interesting mathematical characteristics of the beast number that mathematicians have found as they played with numbers. For example, the beast number is equal to the sum of the squares of the first 7 primes. Or 22 plus 32 plus 52 plus 72 plus 112 plus 132 plus 172 equals 666. It's a sum and difference of the first 3/6 powers. 1626 plus 36 equals 666. There are exactly 2 ways to insert plus signs into the sequence of 1 2 3 4 5 6 7 8 9 to make the sum 666, and exactly 1 way for the sequence 9 8 7 6 5 4 3 2 1, 1 plus 2 plus 3 plus 4 plus 567 plus 89 equals 666. 123 plus 456 plus 78 plus 9 equals 666. 9 plus 87 plus 6 plus 543 plus 21 equals 666. Even more amazing is that the Dewey Decimal System classification number used in libraries for numerology is 133.335, reverse the number and add to get 133.335 plus 533.331 equals 666.666. And just as weird, if you write the first 6 Roman numerals, in order from largest to smallest, you get 666, Tklxi equals 666. In Indian numerology, for example, everyone has 3 relevant numbers that explain and predict human behavior: psychic, destiny, and name numbers, and they mean something different to each person. In Norse numerology, 3, 9, and multiples of 3 and 9 are magically potent. For example, the number 9 is significant in Norse magical practice and often points to Odin. Considered the supreme god in Germanic and Norse mythology, Odin, legend says, hung himself from a tree for 9 days and nights, a time in which he learned 9 magical songs and 18 magical runes. In addition, there were 9 realms of existence, 40 Norse Valkyries, and 13 Norse gods were present when Loki caused the death of Baldur. In China, the number 3 is lucky, and 8 is even luckier. 6 and 9 also run close behind. The number 6 implies that everything will go smoothly. 8 was originally favored by the Cantonese, since in their language 8 means to make a great fortune in the near future, later. The Chinese favored the number 9 implies something everlasting, especially in friendship and marriage. Numbers ending in these digits are often favored today when Chinese people choose phone numbers, room numbers, and car licenses. As for unlucky numbers, 4, unlucky also in Japan, and 7 are at the top of the list. The former implying death and the latter meaning gone. 14 is also bad news. In fact, some cities in China ban the number from car licenses, and many buildings do not have 4th and 14th floors.
What are the measures of central tendency?
The measures of central tendency are statistics that describe the grouping of values in a data set around a common value that in some way represents a typical member. They are broken down into 4 types: median, mode, average. Also called the arithmetic mean, and the geometric mean.
What are antiderivatives and antidifferentiation?
An antiderivative is often interpreted as the same as an indefinite integral. But they actually do differ in definition. Using the notations above describing the fundamental theorem of the calculus. See box text for definition of the fundamental theorem of the calculus. The function f, x, is an antiderivative of f, x, described as also equal to the integral of f, x. The actual process of finding f, x, from f, x, is called integration or antidifferentiation.
How does a person calculate the amount of a tip?
A tip, or gratuity, is the money given to a person who performs a service for a customer, such as a waiter or waitress at a restaurant. Depending on the service, in the United States a 10% to 20% tip is usually left, with the most common being 15%. Although many people have stories about the 0% tip they left after a bad experience. The tip is based on the total bill, the meal and the tax, although some people base the gratuity on just the meal. For example, if a meal at a restaurant costs a total of $10, meal and taxes, a 15% tip would be $10 x 0.15 equals $1.50. The tip is usually left at the table, or given to the waiter or waitress, or taken out by the establishment and added to a tip pot shared by all the wait staff. There are some mathematical tricks to remember when leaving a tip at a restaurant. To a hairdresser, doorman, or in other appropriate circumstances. A good way to estimate a tip is to round the total bill to the most significant place value. For example, an $18.50 meal would round to $20. Next, move the decimal point of the rounded amount one place to the left, $20 to $2. Or 10% of the total cost. Then divide this amount in half to determine 5%, or $2.00/2 equals $1. Add the two resulting amounts to estimate 15% of the total in this instance. $2 plus $1 equals $3 tip. In reality, 15% of $18.50 is $2.78, which is close enough to $3.00. But remember, not every country tips the same. Tipping is a way of life in Egypt, but taxi drivers don't accept tips. French restaurants must add the tip, usually at 15%, to the bill by law. Tipping in Australia is almost non-existent, no one tips in mainland China. Mainly because the government tax on enough charges to visitors, there is no tipping in New Zealand. Either, as the price usually includes services, and don't even think about tipping in Japan.
What are the names given to regular polygons?
Polygons are classified according to the number of sides they have. A polygon with n sides is called an n-gon. The following lists some of the names of polygons, depending on the number of sides. It is also possible to substitute n-gon, when the name is not known, for example 14-gon or 20-gon. Some texts list a two-sided polygon as a digon, but this is only meant for theoretical mathematics.
What is the difference in sum of cubes?
Similar to squares, there is also the difference and sum of cubes that deals with the factoring of polynomials. The difference of cubes takes the form a 3b3, and can be factored into ab, a 2 plus ab and b2. Thus, if an expression resembles a 3b3, then ab is a factor. Use long division to find the remaining factor, s. The sum of cubes takes the form a 3 plus b3, and can be factored into a and b, a 2 ab and b2. Thus, if an expression resembles a 3 plus b3, then a and b is a factor. Again, use long division to find the remaining factor, s.
What is the connection between calendars and math?
A calendar is essentially a numbering system that represents a systematic way of organizing days into weeks, months, years, and millennia, especially in terms of a human lifespan. It was the necessity to count, keep track of, and organize days, months, and so on that gave rise to calendars. All of which also entails the knowledge of mathematics to make such calculations.
The following lists some of them, based on their number of sides. What are the Platonic solids?
Platonic solids are also called regular solids, regular figures. A term also used in reference to polygons, regular polyhedra, or cosmic figures. These solids are convex polyhedra that have equal faces made up of congruent convex regular polygons. To compare in terms of a two-dimensional polygon. A regular figure means that both the sides and the angles between them are equal. There are considered to only be 5 of these solids: the cube, dodecahedron, icosahedron, octahedron, and tetrahedron. These solids were described by Greek philosopher Plato, c. 428 to 348 BCE, in his work Timaeus, thus the name Platonic solids. His definitions were certainly more whimsical than today's. as he believed the major elements were made up of atoms shaped like certain polyhedra. He associated the tetrahedron with the element fire, the cube with the earth, the icosahedron with water, the octahedron with air, and the dodecahedron with the material that makes up the constellations and heavens. The mathematical proofs of these solids were worked out long ago by Greek mathematician and geometrician Euclid. c. 325 c. 270 BCE, in the last part of his Elements, for more information about Euclid. See elsewhere in this chapter, as well as Foundations of Mathematics.
What is a coefficient?
In an algebraic equation, a coefficient is simply a multiplicative factor. In the majority of cases, the coefficient is the numerical part, most often a constant, of the equation. Thus, it is called a numerical coefficient. For example, in 3x equals 6, the coefficient is 3, in -3x equals 6, the coefficient is -3. As the coefficient takes on the sign of the operation, terms such as xy may not appear to have a numerical coefficient. But it is a number that is not written, but assumed. Coefficients do not have to be just numbers. In the equation 5x3y, the coefficient of x3y is 5. But in addition, the coefficient of x is 5x2y, and the coefficient of y is 5x3. Coefficients are also seen in functions. For example, in the function f, x equals 2x, the 2 is the coefficient.
What are tiling and dissection puzzles?
Tiling puzzles are two-dimensional shapes that are reassembled into a larger given shape without overlaps. The best examples of these are dissection puzzles. The most common ones are those in which an object is converted to another by making a finite number of cuts, then reassembling the pieces. Most of the cuts are represented by straight lines, but not always. In addition, sometimes the cut object can be reassembled into two or more shapes.
How did the Hindu Arabic numerals spread to Europe?
Hindu Arabic numerals, often less accurately called Arabic numerals or numbers, had their roots in India before 300 BCE. From there, the use of Indian numerals followed the western trade routes to Spain and northern Africa that were taken by the Arabic/Islamic peoples. This consequently resulted in the expanded use of these symbols. It took several more centuries to spread the idea to Europe. Although the Spanish used some Hindu Arabic symbols as early as the late 900s, records of a more extensive use of these symbols occurred around 1202. Italian mathematician Leonardo of Pisa Also known as Fibonacci, C 1170 C 1250, for more about Fibonacci, cp. 77 and History of Mathematics. Introduced the Hindu Arabic numbers in his book Liber Abaci, the Book of the Abacus. The acceptance of such a numbering system was difficult. For example, in some places in Italy it was forbidden to use anything but Roman numerals. By the late 15th century, most people in Europe were still using an abacus and Roman numerals. The 16th century was the turning point, with European traders, surveyors, bookkeepers, and merchants spreading the use of the Hindu Arabic numerals. After all, it took longer to record data using Roman numerals than with Hindu Arabic numbers. The advent of the printing press also helped by standardizing the way the Hindu Arabic numbers looked. By the 18th century, the new numeration system was entrenched, establishing a system that dominates the way we work with and perceive numbers in the 21st century. For more information about Hindu Arabic and Roman numerals, see History of Mathematics.
How is mathematics used in chemical engineering?
Mathematics is used a great deal in chemical engineering, especially since chemical engineers design materials and the processes by which those materials are made. To solve chemical problems, many types of mathematics are used, not least of which is calculus, including partial differential equations. Even simple calculations, such as working on chemical formulas and equations, involve mathematics. For more information about chemical formulas and equations, see Math in the Physical Sciences. Traditionally, chemical engineers worked in the petroleum and large-scale chemical industries. More recently, they have spread out to the pharmaceutical, foodstuff, polymer and material, microelectronics, and biotechnology industries. Using mathematics, they are involved in such studies as thermodynamics, chemical reaction processes, and process dynamics, design and control. They help to develop new chemical products and processes, test processing equipment and instrumentation, gather data, and monitor quality. Chemical engineers also build mathematical models and analyze the results, mostly to help understand the performance of a process. In fact, the solution to a math problem is often in the understanding of the behavior of the process described by the mathematics, rather than the specific numerical result.
What is bioinformatics?
Bioinformatics is a field that evolved by joining biology and information science. In the past few decades, advances in molecular biology and the increase in computer power have allowed biologists to accomplish tasks such as mapping large portions of genomes of several species. For example, a baker's yeast called Saccharomyces cerevisiae has been sequenced in full. Humans have not been exempt, either. The Human Genome Project was completed in 2003. It determined the complete sequence of the 3 billion DNA subunits, bases, for humans, identified all human genes, and made all the associated information accessible for further biological study. Since that time, other universities and agencies have taken on the task of analyzing the results, such as determining the gene number, exact locations, and functions. Such a deluge of information has also made it necessary to store, organize, and index all the sequence data, which is where information science, or the method to store and work on such large amounts of data, comes in the form of bioinformatics. The computer experts who deal with such information are known as bioinformatics specialists.
What techniques are used to solve first-order differential equations?
There are usually three major ways to solve first-order differential equations: analytically, qualitatively, and numerically. The analytical way includes the examples mentioned above, such as the linear and separable equations. Qualitative methods include such methods as defining the slope of a field of a differential equation. Finally, numerical techniques can be thought of as something close to Euler's method, a way of finding the largest divisor of two numbers.
What is the order of operations when one simplifies an algebraic equation?
Here is a certain order to working out an algebraic equation. The following lists the operations in their correct order. Do what is inside the parentheses. Do the exponents. Do all the multiplications and divisions from left to right. Do all the additions and subtractions from left to right. There are also rules when it comes to grouping in algebraic equations, especially when working with parentheses. When an expression has parentheses within parentheses, work from the inside out, removing the innermost parentheses first. And remember, if there is a positive sign in front of the parentheses, it does not change any sign inside the parentheses. If there is a negative sign in front of the parentheses, it will change all the signs within the parentheses.
Why is there such a demand for applied mathematics in the processing of images?
The field of image processing has grown immensely in the past few decades. There is a great demand for an increase in efficient processing of images, especially for multimedia, biology, and medicine, such as enhancing the quality of electron microscope and MRI, magnetic resonance imaging, images. In addition, there is a great need to develop ways to store more and more information, especially regarding methods in transmitting and processing the information used in computers and networks. All of these things require the use of several mathematical techniques and Thus, the use of applied mathematics.
What are card games?
A collection of cards, or a deck, is a set of n rectangular pieces, usually made of heavy coated paper or cardboard, that holds special varying markings on one side and a uniform, identical pattern on the other. The special markings make each card unique, with each marking representing something playable in a certain card game. The most common cards for games is a 52-card deck represented by 4 specifically colored suits: spades and clubs in black, diamonds and hearts in red, with 13 cards of each suit numbered 1 through 10, followed by several face cards: Jack, J, Queen, Q, and King, K. Card 1 is usually an ace, card 11 is represented by a jack, 12 by a queen, and 13 by a king. The value of the ace often changes depending on the game. For example, it can either hold a value of 1 or 11, in blackjack, or 14, in bridge. Such cards are also used for many gambling games, such as poker and baccarat. Interestingly enough, the investigation of the probabilities of various outcomes in card games was one of the original motivations for the development of modern probability theory. For more about probability, see Applied Mathematics.
Who began the mathematical study of probability?
French scientist and religious philosopher Blaise Pascal. 1623 to 1662, is known not only for the study of probability but for many other mathematically oriented advances, such as a calculation machine, invented at age 19 to help his father with tax calculations. But it performed only additions, hydrostatics, and conic sections. He is also credited, along with Fermat, as the founder of modern theory of probability. For more information about probability, see Applied Mathematics.
What is a linear combination?
Linear combination is a combination or the sum of two or more entities, with each multiplied by some number, with not all the numbers being zero. Linear combinations of vectors, equations, and functions are common. For example, if x and y are vectors and a and b are numbers, then x and by is a linear combination. For more information about equations and functions, see Math Basics and Algebra.
Who was one of the most prolific mathematicians who ever lived?
Swiss mathematician Leonhard Euler, 1707 to 1783. Is considered to be one of the most prolific mathematicians who ever lived. In fact, his accomplishments are beyond the scope of this text. Suffice it to say that his collected works number more than 70 volumes, with contributions in pure and applied mathematics, including the calculus of variations, analysis, number theory, algebra, geometry, trigonometry, analytical mechanics, hydrodynamics, and the lunar theory, calculation of the motion of the moon. Euler was one of the first to develop the methods of the calculus on a wide scale. His most famous book, Elements of Algebra, rapidly became a classic. And he wrote a geometry textbook. Yale University was the first American college to use the text. Although half-blind for much of his life and totally blind for his last 17 years, she had a near-legendary skill at calculation. Among his discoveries are the differential equation named for him, a formula relating the number of faces, edges, and vertices of a polyhedron, although Euler's formula was discovered earlier by René Descartes, and a famous equation connecting 5 fundamental numbers in mathematics. Like many in the Bernoulli family, Euler eventually worked at the Academy of Sciences in St. Petersburg, Russia, a center of learning founded by Peter the Great.
What are some applications of operations research?
Applications of operations research span a wide variety of fields, especially with regard to reducing costs or increasing efficiency. The following lists just a few examples: constructing a telecommunications network at low cost and top efficiency, especially when under high demand or after being damaged. Determining routes of school buses so fewer vehicles are needed, and designing a computer chip that will reduce manufacturing time.
What is ecology?
Ecology, also known as bionomics, is a branch of biology that deals with the abundance and distribution of organisms in nature, as well as the relations between organisms and their environment. It is an inherently quantitative science, with ecologists using sophisticated mathematics and statistics to describe and predict patterns and processes in nature.
What is the atomic formula of predicate calculus?
The atomic formula of predicate calculus is when a predicate and special case of a subject, individual, are written together. For example, if M is the predicate to be a human, and B is the subject, individual, Socrates, then MB means the assertion Socrates is a human. This atomic formula is phrased B is the argument of M. Thus, M, as the predicate, may be applied to any subject, and that subject is then an argument of M. But if C is the subject Vermont, then MC is a false assertion, because Vermont is not a human. Some predicates require more than one argument, thus, you can have formulas such as mxy.
What is Avogadro's number?
Avogadro's number, also called Avogadro's constant or Avogadro's figure, was determined by Italian physicist Lorenzo Romano Amadeo Carlo Avogadro, Count of Quaregna and Cerreto. 1776 to 1856, who was also the first one to use the term molecule in chemistry. It represents the number of elementary entities, such as atoms, molecules, or formula units. In a mole of any chemical substance, a mole is approximately 6.02214199 x 1023 atoms. According to the most recent number from the National Institute of Standards and Technology. To translate even further, a mole is the molecular weight of a substance in grams. 1 mole is the amount of a substance that contains Avogadro's number. For example, the number of carbon atoms in 12 grams of the substance carbon-12 is equal to 1 mole.
Are there different types of prime numbers?
Yes, there are different types of prime numbers, including the following. Mersenne prime. See the box text for an explanation. Twin primes of the form p and p plus 2, in other words. They differ by 2, discovering such a prime involves finding 2 primes. Factorial/primorial primes. Primorial primes are of the form n # plus or minus 1, factorial primes are of the form n plus or minus 1. Sophie Germain primes. This is an odd prime p for which 2p plus 1 is also a prime. It was named after Sophie Germain, 1776 to 1831. Who proved that the first case of Fermat's last theorem for exponents was divisible by such primes. Other names for prime numbers are mainly for descriptive purposes. For example, in 1984, mathematician Samuel Yates defined a titanic prime to be any prime with at least 1,000 digits. In the past few decades since his definition, there have been over 1,000 times more such primes discovered. Yates also coined the term gigantic prime to indicate a prime with at least 10,000 digits. A great deal has happened in the last few decades, so it is only a matter of time before the first 10 million digit prime is found. Although it is still unknown what name that prime number will be given.
What are mathematical sculptures?
Mathematical sculptures are sculptures that represent some mathematical design. They are usually a geometrical figure and can be made of materials such as metal, wood, concrete, or stone shaped into squares, triangles, cylinders, specific curves, rectangles, spirals, and so on. Many of these sculptures represent different mathematical concepts. From polyhedral geometry and topological knots to fractal designs.
What is Boolean algebra?
Boolean algebra is an abstract mathematical system used to express the relationship between sets, groups of objects or concepts. It is important in the study of information theory, the theory of probability, and the geometry of sets. The use of Boolean notation in electrical networks aided the development of switching theory and the eventual design of computers. It was English mathematician George Boole, 1815 to 1864, who first developed this type of logic by demonstrating the algebraic manipulation of logical statements, showing whether or not a statement is true, and showing how a statement can be made into a simpler, more convenient form without changing its overall meaning. Today, this way of looking at logic is called Boolean algebra. For more information about Boole, see History of Mathematics. Boolean algebra did not end there. In 1881 the English logician and mathematician John Venn 1834 to 1923, interpreted Boole's work and introduced a new way of diagramming Boole's notation in his treatise Symbolic Logic. This was later refined by the English mathematician Charles Dodgson, 1832 to 1898, who was better known as the writer of Alice's Adventures in Wonderland, under the pseudonym Lewis Carroll. Today, when studying sets, we call this method not the Boole, Carroll, or Dodgson diagram, but the Venn diagram. Thus, Boolean notation demonstrates the relationship between groups, indicating what is in each set alone, what is jointly contained in both, and what is present in neither. Geometry is the study of figures or objects in space of a certain number of dimensions, and types and focuses on the properties and measurements of points, lines, angles, surfaces, and solids of those objects, or sometimes even the space around them. The word geometry is from the Greek words for earth and to measure. Geometria, broken down into ge and metrion, respectively. A person who studies geometry is called a geometer or geometrician.
How do civil engineers use mathematics?
Although most civil engineers actually spend only a small portion of their time doing calculations, mathematics is essential to this field. For example, civil engineers may use math to carry out the technical calculations in order to plan a construction project. They may use math to model and simulate the possible behavior of a structure before it is actually built. They also use math to understand the necessary chemistry, the strength of a material, and or physical components, how strong parts need to be, of a construction project.
What does the term bisect mean?
The term bisect is important in geometry. It means to cut into two or divide into half, mainly lines, or two-dimensional figures, and angles. To compare, a bisected line segment means finding the plane line, or point that is the midpoint of the line segment. This is also called a segment bisector. An angle bisector is a ray in the interior of an angle that forms two equal angles. First, locate the point on each ray that is equally distant from the vertex. Then draw a third point equally distant from each of the first two rays. A line that extends through the third point and the vertex is the angle bisector. To draw a bisector, follow the sequence, as per the illustration above. First, draw an angle. Then draw an arc centered at the vertex, endpoint, in which B and C are the intersections of the arc and angle lines at equal distances from the vertex. Next, draw an arc centered at B and one centered at C, both with the same radii inside the angle. Finally, extend a line from the vertex to the point D where the arcs of B and C intersect, making AD the bisector of the angle at A.
What is a formula?
In mathematics, a formula is generally a rule, principle, or fact that is displayed in terms of mathematical symbols. Although the Latin plural form of formula is formulae. Formulas is the accepted common use in mathematics. These equations express a definite, fixed relationship between certain quantities, usually expressed by letters, with their relationship indicated by algebraic symbols. For example, scientist Albert Einstein's famous E equals mc2 is a formula representing energy. E, equal to mass, m, times the speed of light, c, squared. The word formula is also used in logic. It is written as a propositional or sentential formula, or a formula in propositional calculus is one that uses and, or, and so on.
Who was Scipione del Ferro?
There were several mathematicians in the 16th century who worked on algebraic solutions to cubic and quartic equations. For more information on cubic and quartic equations, see algebra. One of the first was Scipione del Ferro, 1465 to 1526. Who in 1515 discovered a formula to solve cubic equations. He kept his work a complete secret until just before his death, when he revealed the method to his student Antonio Maria Fiori.
How are the principles of ratio, proportion, and symmetry applied to architecture?
The definition of a ratio is a comparison by division of two quantities expressed as the same unit measurement. For example, a building that is 200 feet wide and 100 feet tall has a ratio of 2:1, 200:100, between its width and height. It is also seen as the fraction 1/2. Such a relationship was understood as far back as ancient Greece and Rome. When people used mathematics to give structure and aesthetics to buildings. This is especially important in architecture, in which building design is based on complex mathematical ratios. Proportion is an equation stating that two ratios are equal. Every proportion has four terms, with the first and fourth terms being the extremes. The second and third terms are called the means. In each proportion, the product of the means equals the product of the extremes. The Greeks and Romans often used proportions in their buildings and other structural designs. The Roman architect Vitruvius was also instrumental in praising the virtues of proportion and symmetry in architecture. For more about Vitruvius, see above. During the Renaissance, architects applied proportion and other mathematical formulas to produce aesthetically pleasing buildings, beauty that still holds true today. Although there are other types of symmetry, the most common is line symmetry, in which a line divides an object, line, or other structure into two equal halves. An example in nature would be the wings of a butterfly. If a line of symmetry is drawn, each point on one side of the line has a corresponding point on the opposite side of the line. If you connect these 2 points, the line is perpendicular to the line of symmetry. There is a more mathematical way of defining symmetry. 2 points are symmetric about a line if the line is the perpendicular bisector of the segment joining the 2 points. Symmetry was used by ancient and modern architects to maintain visual and sometimes structural balance of a building or structure.
How are fractions converted to decimals and vice versa?
In the most commonly used place value, the decimal system, numbers smaller than 1 can be expressed as fractions called decimal fractions. In this system, the decimal fractions are expressed in terms of tenths, hundredths, thousandths, and so on. For example, for the fraction 1/2, or 1 divided by 2, the decimal fraction is 0.5, and vice versa. The decimal fraction 0.5, or 5/10ths, is equal to 1/2. Not all fractions are so easily converted to decimals. It depends on the type of number, especially if it is an irrational or rational number.
What is the historical significance of the barleycorn in measurement?
The barleycorn, just a grain of barley, definitely had a significant historical role in determining the length of an inch and the English foot. For more about the inch and foot, see below. In addition, in traditional English law, the various pound weights all referred to multiples of the grain. A single barleycorn's weight equaled a grain. And multiples of a grain were important in weight measurement. Thus, some researchers believe the lowly barleycorn was actually at the origin of both weight and distance units in the English system.
What was the Principia Mathematica?
In 1910 the first volume of the Principia Mathematica was published by Welsh mathematician and logician Bertrand Arthur William Russell. 1872 to 1970, and English mathematician and philosopher Alfred North Whitehead, 1861 to 1947. This book was an attempt to put mathematics on a logical foundation, developing logic theory as a basis for mathematics. It gave detailed derivations of many major theorems in set theory, examined finite and transfinite arithmetic, and presented elementary measure theory. The two mathematicians published 3 volumes, but the fourth, on geometry, was never completed. On their own, both men did a great deal to advance mathematics, too. Russell discovered the Russell paradox, see below. Introduced the theory of types, and popularized first-order predicate calculus. Russell's logic consisted of 2 main ideas: that all mathematical truths can be translated into logical truths, or that the vocabulary of mathematics constitutes a proper subset of the vocabulary of logic, and that all mathematical proofs can be recast as logical proofs, or that the theorems of mathematics constitute a proper subset logical theorems. Whitehead excelled not only in mathematics and logic but also in the philosophy of science and study of metaphysics. In mathematics, he extended the known range of algebraic procedures, and he was a prolific writer. In philosophy, he criticized the traditional theories for their lack of integrating the direct relationship between matter, space, and time. Thus, he created a vocabulary of his own design, which he called the philosophy of organism.
What is a paradox?
In logic, paradoxes are statements that seem to be self-contradictory or contrary to one's expectations. These arguments imply both a proposition and its opposite. One of the most famous paradoxes was stated by English logician Bertrand Russell, 1872 to 1970, in 1901, and deals with sets. If sets that are not members of themselves are normal, is the set of normal sets itself normal?
How are two-dimensional Cartesian coordinates determined?
With two-dimensional Cartesian coordinates, or rectangular coordinates. An ordered pair of two numbers is determined using two axes oriented perpendicular to each other. For more about ordered pairs, see Foundations of Mathematics. The ordered pair coordinates are found by specifying points along the two axes. First, along the x-axis, the positive or negative amount on either side of the y or vertical axis, this is called the abscissa and indicated as x. The other number is the positive or negative amount on either side of the x or horizontal axis, this is called the ordinate and indicated as y. The coordinates are usually written in terms of x and y at the point as an ordered pair. For example, in the illustration of a two-dimensional coordinate system on P 194, the ordered pair is 7, 8, in which x is 7 and y is 8.
The problem with this proof?
If x equals y, then xy equals 0. Notice that halfway through the proof, the equation was divided by xy, which makes the proof erroneous.
How does one convert latitude and longitude to degrees from readings containing degrees, minutes, and seconds?
It takes simple mathematics to convert the degrees, minutes, and seconds of latitudes and longitudes into degrees only. It helps to know that there are 60 seconds in 1 minute, and 60 minutes in 1 degree. Therefore, to translate 65 degrees 45 minutes 36, also written as 65 hours 45 minutes and 36 seconds, south latitude into degrees, you would do the following calculation: minus 65 degrees, south makes the number negative, plus 45 minutes x, 1 degree slash 60, plus 36 seconds x, 1 slash 60, x, 1 degree slash 60, equals minus 65.76 degrees latitude.
How do engineers determine the escape velocity of a rocket?
A ball thrown into the air will rise and then return, thanks to the Earth's gravity. If the ball is given a larger initial velocity, it will rise even higher and then return. With even more velocity, the ball will reach a certain escape velocity, in which the ball escapes the gravitational pull of the planet. If the ball is launched with an initial velocity greater than the escape velocity, it will rise and not return. In this case, physicists say that the ball was given enough kinetic energy to overcome all of the negative gravitational potential energy, or it launches into space. Thus, if m is the mass of the ball, m is the mass of the Earth, g is the gravitational constant, v is the velocity, and r is the radius of the Earth, then the potential energy is equal to gmm/r. The kinetic energy of the launched ball is equal to mv2/2. This is independent of the mass of the ball. To see how this works to an aerospace engineer, just replace the word ball with space vehicle.
What are the common types of mathematical operations?
Operations are ways to obtain a single entity from one or more entities by manipulating numbers and letters, in certain ways. They include the elementary operations most of us are familiar with: addition, subtraction, multiplication, division, cubing, squaring, and integer root extraction. There are numerous types of other operations, too, including binary operations, in which two quantities or expressions x and y interact in set theory. For more about set theory, see Foundations of Mathematics.
What is an ordered pair?
An ordered pair is two quantities usually written as a, b, that have a significant order. Thus, a, b, does not equal b, a. Ordered pairs are used in set theory to define members in a function. Ordered pairs are also valuable in linear equations and graphing, in which the x-coordinate is the first number and the y-coordinate is the second number, or x, y. They are used on a grid to locate a point. For more information about ordered pairs and graphs, see geometry and trigonometry.
What is solid geometry?
Solid geometry is the study of objects in three-dimensional Euclidean space. It deals with solids, as opposed to plane geometry, which deals with two dimensions. This part of geometry is concerned with entities such as polyhedra, spheres, cones, cylinders, and so on. For more about Euclidean space and dimensions, see elsewhere in this chapter. In geometry, solids are defined as closed three-dimensional figures, or any limited portion of space bounded by surfaces. They differ in subtle ways from what we perceive as solids. We see solids in terms of what surrounds us, three-dimensional figures with their surfaces, the actual objects we perceive. Geometric solids are actually the union of the surface and regions of space. In a way, this adds another dimension to two-dimensional space.
What is an expression in mathematics?
An expression in mathematics is a statement that uses either numbers, variables, or both. For example, the following are all mathematical expressions: y4645x x74 plus 5x, 32, x plus 4x. 7x. In order to write an expression from a written mathematical problem, one has to interpret the text. For example, if one person weighs 100 pounds and another weighs y pounds. The expression for their combined weights would be 100 plus y.
Have computers had an effect on the field of statistics?
Yes, computers have had a definite effect on the field of statistics. In particular, personal computers, software such as spreadsheets and professional statistical packages, and other information technologies are now an integral part of statistical data analysis. These tools have enabled statisticians to perform realistic statistical data analysis on large amounts of data faster and cheaper than ever before. Statistical software systems are most often used to determine examples, understand existing concepts in the statistics, and to find new trends in statistical data. Most of the packages allow the data to be entered into the computer program. But the emphasis then switches to the statistician's ability to interpret the data. There are two well-known programs often used in statistics: the SAS and SPSS, both of which are commercial statistical packages. The SAS system is a statistics, graphics, and data management software package available for personal computers. It allows the desktop computer user to get the quality of results once reserved for users of mainframe computers. The SPSS, statistical package for the social sciences, is also a popular software package for performing statistical analyses. It enables the user to summarize data, determine if there are significant differences between groups, examine relationships among all the variables, and even graph the results.